8.2. Manage quality. Managed quality is a process of translating the quality management plan into executable quality activities that incorporate the organization's quality policies into the project. The key benefits of this process are that it increases the probability of meeting the quality objectives as well as identifying ineffective processes as causes of poor quality. Managed quality uses the data and results from the control quality process to reflect the overall quality status of the project to the stakeholders. This process is performed throughout the project, and it's from PMBOK Guide page 288. Managed quality is sometimes called quality assurance, although managed quality has a broader definition than quality assurance as it is used in non-project work. In project management, the focus of quality assurance is on the processes used in the project. Quality assurance is about using project processes effectively. It involves following and meeting standards to ensure stakeholders that the final product will meet their needs, expectations and requirements. Managed quality includes all the quality assurance activities and is also concerned with the product design aspects and process improvements. Managed quality work will fall under the conformance work category in the cost of quality framework. The managed quality process implements a set of planned and systematic acts and processes defined within the project's quality management plan that helps to design an optimal and mature product by implementing specific design guidelines that address specific aspects of the product, build confidence that a future output will be completed in a manner that meets the specified requirements and expectations through quality assurance tools and techniques such as quality audits and failure analysis. Confirm that the quality processes are used and that their use meets the quality objective of the project, and improve the efficiency and effectiveness of processes and activities to achieve better results and performance and enhance stakeholder satisfaction. The project manager and project team may use the organization's quality assurance department or other organizational functions to execute some of the project quality activities such as failure analysis, design of experiments and quality improvements. Quality assurance departments usually have cross-organizational experience in using quality tools and techniques and are a good resource for the project. Managed quality is considered the work of everybody: the project manager, the project team, the project sponsor, the management of the performing organization and even of the customer. All of these have roles in managing quality in a project, although the roles differ in size and effort. The level of participation in the quality management effort may differ between industries and project management styles. In agile projects, quality management is performed by all team members throughout the project, but in traditional projects, quality management is often the responsibility of specific team members. Managed quality inputs. Number 1, the project management plan. Project management plan components include the quality management plan. This defines the acceptable level of project and product quality and describes how to ensure this level of quality in its deliverables and processes. The quality management plan also describes what to do with non-conforming products and what corrective actions to implement. Number 2, project documentations. These can be the lessons learned register. Lessons learned early in the project with regard to managing quality can be applied to later phases in the project to improve the efficiency and effectiveness of managing quality. Quality control measurements. These are used to analyse and evaluate the quality of the processes and deliverables of the project against the standards of the performing organisation or the requirements specified. Quality control measurements can also compare the processes used to create the measurements and validate actual measurements to determine the level of correctness. Quality metrics. Quality metrics are verified as part of the control quality process. The managed quality process uses these quality metrics as a basis for development of tests and errors for the project and its deliverables as a basis for improvement initiatives. Risk report. Risk report is used in the managed quality process to identify sources of overall project risk and the most important drivers of overall risk exposure that can impact the quality objectives of the project. Input number 3, organisational process assets. These would include organisational quality management system that includes policies, procedures and guidelines, quality templates such as check sheets, traceability matrix, test plans, test documents and others, results from previous audits and lessons learned repository with information from similar projects. Managed quality tools and techniques. Number 1, data gathering. The ones that can be used for this process include checklists. A checklist is a structured tool, usually component specific, used to verify that a set of required steps has been performed or to check if a list of requirements has been satisfied. Based on the project's requirements and practices, checklists may be simple or complex. Many organisations have standardised checklists available to ensure consistency in frequently performed tasks. In some application areas, checklists are also available from professional organisations or commercial service providers. Quality checklists should incorporate the acceptance criteria included in the scope baseline. Tools and techniques. Number 2, data analysis. Techniques that can be used for this process include alternatives analysis. This technique is used to evaluate identified options in order to select which different quality options or approaches are most appropriate to use. Document analysis, the analysis of different documents produced as part of the output of project control processes such as quality reports, test reports, performance reports and variance reports. Variance analysis. These can point to and focus on processes that may be out of control and may jeopardise meeting the specified requirements or stakeholders' exceptions. Process analysis. This identifies opportunities for process improvements. This analysis also examines problems, constraints and non-value added activities that occur during the process. Root cause analysis. This is an analytical technique that is used to determine the basic underlying reason that causes a variance, defect or risk. A root cause may underlie more than one variance, defect or risk. It may also be used as a technique for identifying root causes of a problem and solving them. When all root causes for a problem are removed, the problem does not recur. Tools and technique number 3, decision making. A technique that can be used for this process includes multi-criteria decision analysis. This is used to evaluate several criteria when discussing alternatives that impact project or product quality. Project decisions can include choosing among different implementation scenarios or suppliers. Project decisions can include evaluating the lifecycle cost, schedule, stakeholder satisfaction and risks associated with resolving product defects. Tools and technique number 4, data representation. Techniques that could be used for this process include affinity diagrams. These are used to organise potential causes of defects into groups showing areas that should be focused on most. Cause and effect diagrams. These are also known as fishbone diagrams, YY diagrams or Ishikawa diagrams. This type of diagram breaks down the causes of the problem statement identified into discrete branches, helping to identify the main or root cause of the problem. Figure 8.9 is an example of a cause and effect diagram. Flowcharts. These show a series of steps that lead to a defect. Histograms show a graphical representation of numerical data. Histograms can show the number of defects per deliverable, ranking of the cause of defects, the number of times which processes are non-compliant, or other representations of project or product defects. Matrix diagrams. These seek to show the strength of relationships among factors, causes and objectives that exist from rows and columns that form a matrix. Scatter diagrams. That's a graph that shows relationship between two variables. Scatter diagrams can demonstrate a relationship between any element of a process, environment or activity on one axis and a quality defect on the other axis. Tool and technique number 5, audits. An audit is a structured, independent process used to determine if project activities comply with organisational and project policies, procedures and processes. A quality audit is usually conducted by a team external to the project, such as the organisation's internal audit department, the project management office, or by an auditor external to the organisation. Quality audit objectives may include identifying all good and best practices being implemented, identifying all non-conformity, gaps and shortcomings, sharing good practices introduced or implemented in similar projects in the organisation and or industry, proactively offering assistance in a positive manner to improve the implementation of processes to help raise team productivity, and highlighting contributions of each audit in the lessons learned repository of the organisation. Tooling technique number 6, Design for X, sometimes called DFX. It's a set of technical guidelines that may be applied during the design of a product for the optimization of a specific aspect of the design. DFX can control or even improve the product's final characteristics. The X in DFX can be a different aspect of product development, such as reliability, deployment, assembly, manufacturing, cost, service, usability, safety and quality. Using the DFX may result in cost reduction, quality improvement, better performance and customer satisfaction. Tooling technique number 7, problem solving. This entails finding solutions for issues or challenges. It can include gathering additional information, critical thinking, creative, quantitative and or logical approaches. Effective and systematic problem solving is a fundamental element in quality assurance and quality improvement. Problems can arise as a result of the quality control processes or from quality audits and can be associated with the process or deliverable. Using a structured problem-solving method will help eliminate the problem and develop a long-lasting solution. Problem-solving methods generally include the following elements: defining a problem, identifying the root cause, generating possible solutions, choosing the best solution, implementing the solution, and verifying solution effectiveness. Tooling technique number 8, quality improvement methods. Quality improvements can occur based on findings and recommendations from quality control processes, the findings of the quality audits, or problem solving in general quality management process. Plan to Check Act and Six Sigma are two of the most common quality improvement tools used to analyse and evaluate opportunities for improvement. Manage quality outputs. Number 1 is quality reports. The quality reports can be graphical, numerical or qualitative. The information provided can be used by other processes and departments to take corrective actions in order to achieve the project quality expectations. The information presented in the quality reports may include all quality management issues escalated by the team, recommendations for process, project and product improvements, corrective action recommendations including rework, defect bug repair, 100% inspection and more, and a summary of findings from the control quality process. Output number 2, test and evaluation documents. These documents can be created based on industry needs and the organisation's templates. They're inputs to the control quality process and are used to evaluate the achievement of quality objectives. These documents may include dedicated checklists and detailed requirements traceability matrices as part of the document. Output number 3, change requests. If changes occur during the managed quality process that impact any of the components of the project management plan, project documents or project or product management processes, the project manager should submit a change request and follow the Perform Integrated Change Control Management process. Number 4, project management plan updates. Any change to the project management plan goes through the organisation's change control process via a change request. Components that may require a change request for the project management plan include quality management plan. The agreed upon approach to managing quality may need to be modified due to actual results. Scope baseline. This may change as a result of specific quality management activities. The same with the schedule baseline and the cost baseline. Output number 5, project document updates. Project documents that may be updated as a result of carrying out this process include the issue log, the lessons learned register, and the risk register. And that brings us to the end of the managed quality. The next lesson is 8.3, control quality. Please read the corresponding chapter in the PMBOK guide before watching the video.